Here we have section 3.4, exercise 46. And this is a technology one. They tell us that our function is the square root of 2x times sine of x. Excuse me. And we're on the interval, closed interval, 0 to pi. And bottom line, let's see, they want us to find first and second derivatives, relative extrema, points of inflection, and get the graphs and so forth, and look at the behavior. Okay, so the derivatives themselves aren't so bad. You know, if I do this using the product rule, you know, this is 2x to the 1/2, so I would have 1/2 2x to the negative 1/2, and then times 2, so those of course would disappear, all times sine x, and then plus that square root, or 2x to the 1/2 times cosine x. Now, but, you know, here's where it gets really nasty, is, you know, if I set that equal to 0, now I can multiply through, right, this square root of 2x is on the bottom, multiply everything through by the square root of 2x, and what happens is you get sine x plus 2x cosine x equals 0. And that starts getting kind of hard. You know, I could, you know, make this like, well, actually, I'm going to do it the other way. I've got 2x cosine x equals negative sine x. And so then I could make this 2x is equal to minus sine x over cosine x. And, you know, I could put that 2 under here as well, I guess, so make that that. Okay, but there's, you know, x in terms of x. That starts getting hard, and I might want technology to do that for me numerically anyway, you know, and similarly, you know, the second derivative starts getting nasty. Okay, so going to technology, you know, here we have Desmos, and here's kind of from 0 to 2 pi, square root of x sine x, square root of 2x sine x, and, you know, there's the graph, and all I had to do was then say f prime, and so now we see this, and if I go here, I can find the zeros at 0, 0, at 1.837, and at 4.816. Okay, so I have 3 places, 3 critical numbers in this interval. One is right at the end point. The rest, yeah, the rest are not. And, you know, so I've got those critical numbers. I can get those off of there. And I see, you know, just from the graph, I can see that I have a relative maximum, relative minimum here. And this, well, it's an endpoint, so not clear what would happen there. But I can check concavities, and, well, maybe. There we go. And here, then, okay, so the concavity you know, the concavity changes at these spots. Now, what's that last one? 6.436. You know, what's 2 pi? That's really close to 2 pi. And, right, because 3 point, you know, so, you know, if you're just kind of wondering, well, just type in 2. And go here and write pi. And 6.238. So you see that was just a little outside of the 2 pi. And so, you know, here the green one, the second derivative is positive all through there, and then negative all through here, but, you know, so it's positive there, concave up, yep, or relative minimum, relative maximum here where the derivative was, second derivative was negative, and then again positive over here and concave up again, you know, so we've got those concavities, and you know, so we can look at those second derivatives. There are the graphs, you know, and I can do that pretty easily and quickly with Desmos. Now, you know, what are the actual derivatives? Well, I went to Sage Cell, and you know, I said var x. I typed in f equals my square root of 2x times sine x, showed f. Then I computed the derivative of f with respect to x, showed that, called it fp. Then I took the derivative of fp with respect to x, called that f double p, showed that. And then I also tried solving, you know, fp equals 0, you know, f prime equals 0 for the critical numbers, called that c and said showed c, hit evaluate, and so you see, you know, here is, you know, pretty much what we got for the first derivative. Second derivative starts looking mighty ugly. And then notice they got the same answer I got, right? You know, I said, please help me solve this for x. They didn't do any better than I did. You know, so that it's sort of helpful, but not real helpful. You know, so the technology didn't do any better. But, you know, I've got the derivatives using, you know, these pretty simple, straightforward commands, and hit evaluate in a Sage Cell, and you know, it's very nice. I got those derivatives. You know, they're not necessarily simplified in the best way or anything, but there they are. Okay, so that is looking at the various pieces of number 46.